we're going to take our parallelograms and make them a little bit more specific. So our rhombus is a parallelogram, but it has 4 congruent sides. So not only are the opposite sides congruent, all of them are congruent. Our rectangle is a parallelogram, but it has 4 right angles. And then you take a rectangle and a rhombus, put them together, and then you have a square. So it's got 4 congruent sides and 4 right angles. Okay, and on your notes, if you want to draw them, I would suggest drawing them and using our tick marks to label the congruent sides. Right angles. And put it together for a square. Is that what this was supposed to look like? So for our rectangles, we have some properties that are special to our rectangles. So it is a parallelogram. So all those 5 properties you guys just named off also apply to our rectangle. So our opposite angles congruent. Yeah.
Yes.
Because all right angles are congruent, right? So opposite sides are congruent. Opposite sides are parallel. Consecutive angles are supplementary, equal 180. Okay. Special one to rectangles though is that our diagonals are congruent. So go ahead and underline that, highlight it, whatever on your table.
This is the first time that that's happened. Never.
And you have those properties that are special to rhombi. Okay, so it is a parallelogram, so opposite sides are parallel, opposite angles are congruent, opposite or consecutive angles are supplementary. All of those 5 properties still transfer over. But now we have our diagonals are perpendicular. So go ahead and label that on your picture. Our right angle. All of them are? All of them are. So you could do all of them. You wanted, or you just do one to kind of make a note to yourself. And another special one for rhombuses is that each diagonal bisects a pair of opposite angles. So these 2 are congruent to each other.
So the same angle?
Yep, so our diagonal that goes across makes 2 congruent, so they bisect. So I know it's kind of hard on your paper because it's not color-coded, but then you have 4 congruent little angles on it. You might, list it, circle them, or say these 2 are congruent. This example is on the front of your notes. Okay, we're trying to find TV. I'll highlight. Nice little pink. Okay, so what do we know about sides of a rhombus? You know it's a rhombus. All sides of the rhombus are equal. So I can put this equal to this, this, and this. So what did we do with parallelograms when we had a variable on sides?
You add them up.
I want to add them up.
Add them up, but
Set them equal.
We can set them equal to each other since they're congruent. So I can do 13b minus 9 equal to 3b plus 4. Do some subtraction pose. That's going to give us 10b minus 9 is equal to 4.
hold on.
You can write as a fraction or you can write it as a decimal. Either one. So now that I have V, I can put it into either one of our circled ones. And that'll give us one of the side lengths. So if I find WV using the 13 times V minus 9, substitute it in, do 7.9. That's WV. But we're looking for TV. We're looking for, it asked us for TV in the question. We just found WV.
Well, your angle, all sides are the same.
All the sides are the same. So that's also TV's length. This is another example. We're looking for B, T, Z. So this angle that I just highlighted.
Okay.
And we know we can set it this equal to 90 since it's a perpendicular bisector.
90. We already know what it is, right?
Use some algebra 1 to solve for A.
So that's what
What's 110 divided by 14? Put it in your calculator. Oh, wait,
Wouldn't
Track
that
it
be
wrong.
70?
you're right. So 70 divided by 14 is 5. So now that we have A, we can find this angle right here using the 5A minus 5. And how does that help us find angle BTZ? What do we know about this angle and this angle, the highlighted one? They're congruent since the diagonal bisects it. So we have 5 times A minus 5. And that is 20. That is our angle measure. So then we have our square that we've known since like first grade. Takes all of the rectangle properties, all the rhombus properties, pushes them together so you have a lot more properties of a square. So we now know that our diagonals are congruent from our rectangle property. We have that our diagonals are perpendicular bisectors. So rhombus property. What else do we have from our rhombus property? You just told us.
The diagonals.
90 degree.
Or we already got that in the middle. They're 90 degrees. What else?
What would this angle be?
45.
It would be 45 degrees because our diagonal bisects a right angle.
So what's the main thing that makes a rhombus a square? No, that already happened in a rhombus. The angles are bisected. Come on, you guys. What's the main difference between a rhombus and a square? It's obvious. Back to third grade.
What's the difference?
The main difference.
All 4 angles are 90 degrees.
Good. Yeah, you guys have known that forever and a half, right? So it's like a square is a rhombus that is standing up straight, right? That's all it is. All right, I want to see if they can do this one with those properties up on the board. So our goal here is to prove that this is a square by means of 3 really important words. The word congruent, the word perpendicular, and the word bisector. So over on the board, you can see I have 3 different hints to you. To prove that 2 segments are congruent, what do we have to do? Yeah, it's no hints. It's on your notes, right? It's a distance, or it's not. Sorry, it's on the screen. The distance formula, right? If they're the same distance, then what does that mean? Yeah, they're the same length, so they are congruent. Okay. The next word is perpendicular. We learned about the word perpendicular a couple essential standards ago. If 2 segments are perpendicular, they have opposite reciprocal slopes. So you might write that down. It's up on the board too. What does it mean for 2 slopes to be opposite reciprocals? Like, let's say the slope of one line is 1/2. Rise over run, 1/2. what is the opposite reciprocal of 1 over 2? 2 over 1, and you have to change the sign. So it'd be negative 2 over 1, or just negative 2, right? What's the opposite reciprocal of negative 4/3? Positive 3/4. Good job. So if you can show me that the diagonals have opposite reciprocal slopes, then they are perpendicular. And lastly, if they are bisectors, that means they cut each other in half at the same point. They have the same midpoint. So it's been a while, but up on the board I have the midpoint formula. It's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. It's literally the middle point, right? So what's another word that we use in math for adding 2 things up and dividing by 2? Or adding 3 things up and dividing by 3? Or adding 14 things up and dividing by 4? What's that word called? The average, yeah. So we're literally finding the average of the x's and the average of the y's. Okay, so take a little bit of time and see if you can prove this is a square by doing those 3 things. And they're all based on the diagonals, right? So the diagonal going from E to G, and the diagonal going from F to H. That's what you're using for all 3 of these scenarios. Okay?
Bing! Alright, so what did you get for the distance of EG?
Were they supposed to be different?
50. Yeah. Not quite 50.
That's what I got.
The square root.
Square root of 50.
Oh, yeah.
What about for FH? Not just 50. Square root. You're going to take the square root of all of that. So, are diagonals congruent? Yeah.
Yeah, they come out to the same.
Check that off. Okay. What was the slope of EG?
So from E to G, what's the rise over run?
1 over 7.
So on here, up 1 over 7, right? What about FH? Now you have to do rise first, right? Rise over run. So how far do you have to go to get from F down to H? Good, it's down, right? So what do we call down? Negative 7. And then how far do I have to run?
1. So are the diagonals perpendicular?
Yes.
They're opposite and reciprocal, so we'll check off the perpendicular. What about the midpoint? Midpoint of EG. Should have been an ordered pair, an XY. Did we get that far yet? Ooh. Okay. We find the averages of our 2 points. It was negative 1/2. Negative 1/2. If you look on your diagonal, looks like it's about right there.
The left 1/2, down 1/2, right? Does that look like it's in the middle of the EG?
Yeah.
Yep.
And for FH, it was the same. We did the formula. Okay. So again, so they share the same midpoint. So now we know that they're bisectors.